The next thing we gotta do is create the property this dot n equals 0, which keeps track of the which term like n we're on. Then the next thing we are going to do is we're going to create an array called this dot data points, which equals just an empty array. Lastly, we're going to have this dot travel speed equal travel speed. Next, we're going to create a function that initializes this equation and allows us to continue on with the process of the simulation of this equation object equal function. So it's just going to be called initialize data points function. So we're going to have a var starting x, which equals x min, and then this starting x is you're going to add this dot step to it each time you make a new point, so that each point is a step away from the other point. So we're going to go for var I equal to 0, I smaller than number of data points, I plus plus. We're just going to say this data points dot push new data point. So a data point should know it's starting x, where it starts in the beginning, x-wise, because it's not going to really change. And it should know how fast it should travel. It should know its travel speed. And then after that, after we set this data point to a certain starting x, we have to adjust that starting x. Starting x plus equal this dot step by a certain step, so that the next point is slightly to the right of the previous point, creating a line, like a dot of lines that looks like a nice continuous line. Okay, so now we're done with this dot initialized points data. So right here we said new data point. So this is actually not an actual function yet. So we have to create this function or object, sorry. So we're going to say data point. So data point, as we said, takes in x start, and it takes the speed of travel. So I just like to make these variables not the same. Why is it not? I like to make these variables not the same as the variables we're passing into them, so that I can just tell a difference. So I name it really close to what we're passing in, but not exact. So what should a data point object have? So we kind of already talked about this. So a data point should know where it is. So we're just going to say it should know its position, which we're just going to say pos equal create vector. A vector holds two values, the x, or it can hold three values, but we're only going to hold two values, an x and a y, which we're just going to default at 0. A vector should know its speed in the x and y direction. So speed can be a vector. Oh. Create vector. So let's just default the x and y speed to 0. An object should know its speed of travel, which equals speed of travel. This object should know where it needs to be to fulfill the next Maclaurin series, which we kind of talked about. And that's just going to be where it needs to be is also going to be another vector. 0, 0. We're just going to default it at 0, 0. What else? It should know if it's traveling or not. Is traveling based on where it is and where its destination is. So we're just going to default this at false. And lastly, we're going to have this we're going to have this property. I'll explain this property later, but it's going to be called scale. And just trust me on this. It's width divided by 2 parentheses from that divided by 5. And I'll talk about this property later. So now we have a data point object. So now this line of code makes a little bit more sense. So the next thing we're going to do with the equation object is we're going to create a function called this.nextTerm. And so what should this.nextTerm do? Well, this.nextTerm is going to be the function that we use to create the next partial sum of the Maclaurin series. So the first thing we're going to do is we're going to say var x value equal x min for similar reasons why we did this line, so we can keep incrementing the x values of this dot of the data point objects, and we're gonna loop through all our data point objects. Var c equal to 0, c smaller than number of data points. I could also put this dot data points dot length if you want to do that. It's the same thing. And so we're going to talk about, we've talked about the general term for the Maclaurin series, and that will come really in play with this for loop. So the general term of sin x Maclaurin series is -1 to the n times x to the 2n plus 1 divided by 2n plus 1 factorial. So this is so cool that we have a general term. We have a very specific equation. Unfortunately, this specific equation is not browser friendly. It's not code. It's not JavaScript friendly. If you put this into a browser, a Chrome browser, it won't know what to do. So we have to make this expression into JavaScript, a JavaScript-based expression. So how are we going to do that? Well, we have a function called pow. Sounds funny, right? Which is a P5js function that takes a base and an exponent. So we have, we have to create a variable that holds this general term. Var term n equals. So it's not really the general term in the sense that when we get this variable, it won't be a general term, but it will more be an exact specific term. So it's going to be a specific term based on the n we have and the x value, because we're going to plug specific values into these based on what the equation object knows about these values. So like I said, we have a power function that takes in a base, which in this case is -1, and an exponent, which is n. So we have to say -1 comma this dot n, because this dot n is the property, times pow takes in a base of x, and in this value x is, in this case, x is x value, and the exponent is 2 times this dot n plus 1. Okay, so we have that, and then we're going to divide this whole expression. We're going to put parentheses around this whole expression. We're going to divide this whole expression by the factorial of 2 times this dot n plus 1. So this is all JavaScript based, so the browser will know what we're talking about. The only disclaimer is this factorial. So this is actually not a function in JavaScript. So we're actually gonna have to create this function, which will be quite easy. We're gonna have a function called factorial, and it'll take just a value n. So let's just talk about how factorials work. So you might know, but let's just at least give some time to this. Okay, so the factorial 5. So the factorial 5 equals 5 times 4 times 3 times 2 times 1. So we can represent this by giving a value of 5 into this function. We have to somehow create an expression that is this. So the first thing we're going to have is a variable called multiplier, and it's going to equal 1. So the reason why this multiplier equals 1 is no matter what kind of factorial you have, 0 to infinity, factorial could never be less than 1. It has to always be greater than or equal to 1. So the multiplier will equal 1. The next thing we're going to do is we're going to have a for loop for var m equal to 1, m smaller than or equal to n plus plus. Oh, okay, so now we have this for loop, var m equal 1, m smaller than n, m plus plus. So now we're going to type in here multiplier times equal m. So, and then after we do the for loop, we're just going to return multiplier. So let's see how this works. Okay, so we are given the value, let's say 5. So we're going to say var m equal 1. M, in this case, is equal to 1. 1 is smaller than or equal to 5. That is true. So it's going to go through here, and it's going to say multiplier times equal m, which in this case equals 1. And it's going to plus it, and now it's 2. 2 is smaller than 5, so it's going to be 1 times 2 is 2. And it's going to be 3, 4, 5. Once it gets to 5, it's going to say 5 is smaller than or equal to 5, which is n in this case. And so it's going to do multiplier times equal 5, so it's going to multiply 5. And then when it gets to 6, it's going to say, hey, 6 is not smaller than or equal to 5, which that's what we passed in for n. And it's going to say, stop the for loop, stop what you're doing. And now, once we stop what we're doing, we're going to return the value multiplied. And that will be this value, which equals this. So that's how that works. So now we're done with that. The next thing we need to do, after we have the variable term n, properly found and coded, is we're going to do this dot data points c dot destination dot x equal x val. So we're setting where these data points need to be. So based on the term, the general based on what x value on, we're going to create a certain term n. And so we're going to say to this data point, your new destination is going to be this x value, and your new y destination is going to be equal to the partial sum, which is the partial sum, which is the data points dot pos dot y plus the new term we're adding onto you. So another way you could see this is where you are plus what we want plus what we've added to you. So this is where you are, your position, plus the extra term we added. Another way you can see this mathematically is all the partial sums that led up to this moment plus the new partials plus the new term, which creates a new greater partial sum, which is going to be put into this destination. Okay. That's correct. Next thing we're going to do is we're going to say this dot data points at c dot create point speed. And this is a function we're going to create. This function sets the speed of the point in the x and y direction. So I know what you're thinking. You're saying, hey, we already have the speed. The speed is right here, speed of travel. Well, the speed of travel is actually technically not the speed of the data point. It's kind of a bad name if now looking back at it, but the speed of travel is actually saying, is actually going to be the variable that says, how many steps do you want me to take to my destination? So if I'm at 0 for my y value and I want to be at 10, and I say take 10 steps, then speed of travel equals 10. Take 10 steps. But what is your actual speed? Well, you have to calculate that. Well, it would be 10 divided by 10, so your actual speed is 1. So we're going to do that in this function. So we're actually going to calculate the speed of this object. So the first thing we're going to do is say this dot create point speed, create point speed equal function. And then we're going to say this dot speed dot x equals this dot destination dot x minus this dot pos dot x divided by this dot speed travel. Then the y speed is exact same, except you just change these properties y dot y dot y. Okay, so pretty much what this is saying is, hey, you need to be at 10. You're at 0 right now. I'm telling you to take 10 steps. So you say 10 minus 0 is 10 divided by how many steps you should take equals your speed, which is 1. And that's just an example. So now we've created a point speed. And that's pretty much it with that function, except we have to do one more thing. We have to increment the x value. So x value plus equal this dot step. Kind of like how we incremented it the last time up here. Okay, so we can just save that. I'm just saving it just so that if anything happens to my computer, I have it. But we're actually not doing anything with it right now. Okay, so the next thing we have to do is we have to create an update function for this data point. Pretty much an update function will take the speed of this object and add it to the position. So if you're at 0 and you need to be at 10, we'll add, and your speed is 1, then we're going to add your speed, and that's what the update function is going to do. So let's just create an update. This dot update equal function. So this dot update equal function. So another thing that update has to check is if oh, one more thing. When you're creating a point speed, we have to also think about, is this point traveling? Is this data point traveling? Well, if you're creating a point speed, that means that you have a destination that you need to be going to. So by definition, you must be traveling. So this dot is traveling equal true. Okay, so update is uses the is traveling boolean, and you only update your position if you need to update it. So let's say you're already at your position, then you don't need to update your position because you're already at your sorry, if you're already at your destination, you don't need to update your position because you're already at where you need to be. So only if you are traveling, that's the only time you should be updating your position, because that means that you're still traveling to where you need to be. So that we're going to say this dot pause dot x plus equal this dot speed dot x, this dot pause dot y plus equal this dot speed dot y. Okay. And then we're going to say, in this update function, we're going to call a quick boolean function. So we want to know, after we've updated your position, are you where you need to be? So we're going to use this function called dist, which calculates the distance between 2 points using x1, y1. It takes an x1, y1, x2, y2. So the first point is going to be this dot pause dot x, this dot pause dot y, this dot destination dot x, and this dot destination dot y. So if your distance is smaller than this dot speed dot y divided by 2, then that means that you've reached your destination. Basically, let's say your speed is 0.5, and you're 1.2 pixels away from, or values away from your destination. That means that if you added 0.5 to your that means that pretty much 1.5 is greater than half your speed. So that means that you still need to be going. I chose half the speed. Technically, you can actually just use smaller than this dot speed dot y. But sometimes when the pixels are starting to round, the distance between the 2 points starts to get kind of iffy. So it's just good to use a value that is constantly changing based on a specific on this specific dot, but just slightly smaller than it, just in case. So that's why I used half that. Okay, the next thing is, so if your distance is smaller than that, that means that you're done traveling. So we just say this dot is traveling equal false. Otherwise, else, this dot is traveling equals true. So you're still traveling if you haven't met that requirement. And that's the update function.